Hello students, this video is for Unit 1 Lesson 8, which is about the segment partition concept again. This time we're going to be using a formula to try to figure out where the point is that splits the segment into two different parts. Keep in mind that you can use the graphing method anytime that you're given a graph, but this segment partition formula is always going to work, and it's going to work especially with larger values that you can't necessarily graph, and it's also a great way of showing your work. Alright, without further ado, let's get to it. Let's review the learning target for this lesson. It tells us that we're going to be able to partition a segment. Just like the previous lesson, we partition a segment by identifying a point that splits a line segment into two parts. But in this case, we're going to be using a formula. So I'm going to show you the formula, and then I'm going to show you how it works. And then identifying the point, that's the same idea as the last lesson. We're identifying whatever point it is, for example, 1, 5, by its coordinates. All right. The do now, it asks you to find an equation of a line that passes through these 2 points. Now keep in mind, in order to find the equation of a line, you need 2 different pieces of information, which are the slope and the y-intercept. So in order to answer this question, we need to find the slope and the y-intercept between these 2 points, 2, 16 and -1, 7. Pause the video, try this one out. This is a question as a review from algebra. Try this out and see if you can get it right. Alright, that first step was to find the slope, and we found the slope by using that slope formula. You do have to memorize this formula. Change in y over change in x. y2 minus y1 over x2 minus x1. Substitute the values, get a simplified version, and simplify even further. Negative divided by negative is a positive. So we have the slope, which is equal to 3. Now we need to find the y-intercept, which is simply substituting that slope and one of these 2 points, doesn't matter which one, into the equation y equals mx plus b. Here's what it looks like. Alright, once again, we wrote down y equals mx plus b. We substituted -1, 7 into this equation. We chose -1, 7. Well, I chose it because these numbers are smaller than these numbers. 16 would be a little bit harder to work with. Even though there is a negative number in there, that's okay with me. It doesn't matter, we could have chosen either point. So we multiplied everything out, and we got 10 is equal to b. Now we can identify the equation of the line that passes through these 2 points, and let's graph it just for good measure. Alright, here's our equation, here's our graph. We labeled the graph, of course, because you must do that every time. And if you notice, I'll put this point here. The reason I put the point there is just to verify that this is the correct linear equation. And you'll notice that this point is -1, 7. I wasn't able to verify that second point because 2, 16, well, frankly, it's just too high. But I'm assuming that I've done it correctly because it passes through that one point. Alright, moving forward to the actual lesson. And you'll notice that the vocabulary section on the left-hand side is exactly the same as the previous lesson. All we're talking about is ratios. And remember that a ratio is a comparison of 2 different values, two different quantities, and we're able to take a ratio like 4:2 and reduce it to a ratio of 2:1 as long as it has a common factor. And remember that partitioning is to split a line segment into 2 different parts, which each have perhaps different, perhaps the same measurements. For example, this one's 5 units, this one 2 units, for a total of 7 units, and the ratios numbers add up to the total number of units there are in the line segment. The difference here is that I'm telling you about the so-called formula method. The formula method for partitioning the line segment is an algebraic way of getting the point, not by using a graph, but by using algebra. And you'll notice that it uses some of the same symbols as the distance formula, like x1 and y1, and it's got this y2 minus y1 and this x2 minus x1 concept, which is really the difference or the change in x, the horizontal change, and the difference or change in y, the vertical change. But it also has this a over a plus b, and the a and the b are defined as parts of the ratio. For example, in this ratio, 5:2, we made it real simple for you. The first number that comes up is a. The second that comes up is b. So this is a, this is b. So the ratio is going to look like this. If we were using the ratio of 5:2, we would have a 5 as the numerator, and then the denominator isn't just going to be 2, because it doesn't just say b, it says a plus b, which is 5 plus 2. So our ratio for 5:2 is going to be translated into 5 divided by 7. 5 meaning the number of parts on the left-hand side, divided by 7, which is the total number of parts. Alright, it should be fairly straightforward to use this formula. All you need to do is substitute in. Let's take a look at a couple of sample problems. Now, you should remember that we did these problems before. We actually did them yesterday. And you'll see that the answer is already here. The coordinates of P are -2, 2. Well, that should make it fairly easy for us to figure out the answer by using another method and then verifying that method using the correct answer that we already know. Now, the first thing I'm going to do is put that partition formula down. This is a formula that you are going to have to memorize, but remember there are some parts of it, like this x2 minus x1, this y2 minus y1, that you'll be able to just simply remember from other different formulas. So you don't have to remember that specific piece. You do have to remember some of the specifics with the a's and a plus b's. Now, once you write down the formula, you can do that substitution, and we've already labeled these points, so it should be fairly straightforward. The only difference is we don't have the a's and the b's labeled yet. So be sure to label those a's and b's. That comes from the ratio of whatever number is here to whatever number is here. All right, let's see some substitutions. All right, so this might seem like there's a lot of stuff going on here, but honestly, all I did was take the information from the problem and substitute it into the formula. I got this -5 from the first x value. I got this 4 from the first y value. This 1 over 1 plus 3, that's simply the ratio turned into a over a plus b form. And this 7 minus -5 and -4 minus 4, this should be familiar to you. This is just x2 minus x1 and y2 minus y1 respectively. I did forget a parentheses at the end of here because we need an end parentheses, this big end parentheses. Now let's try to go through using PEMDAS, looking at parentheses, exponents, multiplying, dividing, etc. Looks like that first step is going to be to evaluate this operation, which is in the parentheses, the 7 minus -5 and the -4 minus 4. And while we're at it, we can consider the individual numerators and denominators of a fraction to sort of be parentheses in and of themselves, because it's 1 divided by the quantity 1 plus 3. So I can evaluate the denominators of these fractions at the same time. All right, hopefully it looks a lot less scary. We've evaluated the fractions denominators, and we've also evaluated the y2 minus y1s, x2 minus x1s, and we got something that looks a little bit easier to work with. Now let's identify the next thing that we can compost down or simplify. I got 1/4 times 12, and I got 1/4 times -8. That's the multiply step, and it's going to go first before the addition step. So let's do that. And 1/4 times 12 is 3. 1/4 times -8 is -2. We can simplify this fairly easily, and lo and behold, we should get the answer, -2, 2. And you can pat yourself on the back for a formula well done. -2, 2 is that partition point. It's the point that splits this line segment into a ratio of 1 to 3. Amazing. Take a look at the check for understanding. Again, you've already done this using the graphical method, but instead of using the graphical method, if the problem asks you to use that algebraic method, or if you like formulas better, you must use that other method. So try out the formula method, pause the video, and then come back to see if you got it right. All right, not too bad here. Follow along. We have x1 and y1 are both -9, so they go here in the front, this -9 and -9. The a over a plus b section is just 3 over 3 plus 4, which turns out to be 3 over 7. And then this x2 minus x1 and y2 minus y1 evaluate to 14 and 7 respectively. We're multiplying 3/7 times 14 and 3/7 times 7. We get 6 and 3 respectively. Then we just add them up and get -3 and -6. And hey, guess what? The coordinates of P are -3 and -6. Not too shabby. Now keep in mind, what we're doing here is we're trying to identify the point that partitions AB into the ratio of whatever it is, 3 to 4, 1 to 2, etc. One thing that you should keep in mind is that sometimes problems will look like this. They'll have a little disclaimer on the bottom that says use of the coordinate grid is optional. The thing that they mean by that is you can use the graphical method if you would like to. However, sometimes the graphical method will not work in problems like these. So you need to be able to have two methods to solve. Sometimes you'll be able to use that graphical method, but as I said at the top of the video, sometimes the points will be too large and you won't be able to graph them, or sometimes you will need to show your work. It'll say use the algebraic method or the formula to prove it. So you need to have two different methods on your belt just so that you are covered. One more quick thing before we close the video out. All of these problems that we've done so far talk about a ratio of like 1 to 3 or a ratio of 3 to 4. What happens if it asks you for partitioning a line segment into the ratio of 1 to 1? Well, you should think about the ratio of 1 to 1 as the exact same number of parts being on one side versus the other side. That should make you think, what is the name of a point that splits a line segment into the same number of units on the left-hand side of it and on the right-hand side of it? Here's a graphical representation of what that looks like. What happens if the question asks you to split a line segment into the ratio of 1 to 1? Well, this point should look very familiar to you. It's a point that we learned about during this same unit. That point, of course, is called the midpoint. Again, the midpoint is a point that splits a line segment in half, each of the halves being equal parts. So the midpoint splits a line segment into the ratio of 1 to 1. The midpoint formula also is a special version of that line partition formula. Let me show you what I mean. The one thing that I want you to see here is that in the partition formula and in the midpoint formula, I'm doing x1 plus eventually our x2, and I'm also doing that same thing here. The thing that I want you to notice also is that here I have a ratio of a divided by a plus b, whatever that happens to be. Remember, the a is the first part and the a plus b is the first part plus the second part of the ratio. Well, if I took this ratio, this 1-to-1 ratio, and I added the a plus b together, I'd get 2. So the ratio that I'd be multiplying by is, of course, 1 divided by 2. That's where this divided by 2 comes from in the midpoint formula. So you should be able to see that the midpoint formula is a special version of the partition formula. All right, that lesson was all about the segment partition method, specifically about formulas. Good luck studying.